In this video, we're going to look again at the behavior of polynomial functions, focusing primarily on number of turns, but we will review some of the other things that we've looked at in the previous videos. So the first thing we need to look at is we need to look at the degree of our polynomial, and when we're looking at this polynomial here, we can say that this is a first degree because this is the same as x to the 1. So this here is a first degree polynomial. So a first degree polynomial is linear. It's also an odd function because our exponent is a 1. So let's talk about number of turns. So we can see right here that there are 0 turns. Okay? So a first degree has 0 turns. So the number of turns is always 1 less than the degree. So there's 0 turns. The last thing I want to do with this one is just kind of review that how I know how the end behavior is going to be. We can see that this is also a negative function. So a negative function is going to have a negative slope, which we can see right here. This is a negative slope. So when we talk about end behavior, we talk about the left side. So the left side is where x is approaching negative infinity. What's our function doing? Well, our function is going up. So if it's going up, that means our function is going to positive infinity. So right here, this is our left side, and it's going up. And then over here, we have our right side, and that one's going down. So on the right, I have x is going to infinity, because infinity is this way, and my function is going down. So my function is going to negative infinity, which is down. Okay, so that was a review. Let's go ahead and look at this next function over here. So what degree function is this? We're going to look right here. This here is a second degree function. And how many turns do we see? We see it has 1 turn right here. It has 1 turn. So you can see the turn is 1 less than the degree. We also call this a quadratic. It's even because my exponent is even. And it's also positive. So we see that it's positive because the lead coefficient is positive. So for an even degree function that's positive, both ends go in the same direction, and we can see that right here. They're both going up. So let's review end behavior. So on the left side, it's going up, and on the right side, it's also going up. So we're going to write our left side to be as x goes to negative infinity, our function is going up. On the right side, we can say as x is going to positive infinity, my function is going up. So that's also infinity. So that there is end behavior. Let's just make a little note of that both of these here are end behavior. Okay, this is also end behavior. And that's a review. Okay. let's look at this next function here. So we can see that these kind of graph, each one kind of graphs a little differently depending on the function. So let's look at this function. What degree function is it? So we're going to look at our highest degree. Our highest degree is 3. So this is a third degree function. And how many terms does it have? It actually has no turns. This is not considered a turn. This is just a little indentation. So this here has 0 turns. Well, let's look at the one next to it. So let's compare these two. So this is also a third degree. And how many turns does this have? This has 1 turn. This has another turn. So this has 2 turns. So we can see that our third degree could either have no turns or 2 turns. Notice that it's always at least 1 less than. Okay, this is not a turn. This here is a little dip, which is called an inflection point. So if you take calculus or pre-calculus, you will know this is an inflection point. It's right there, but we don't need to really worry too much about that. Okay, so getting back to this first one here, this is odd. It's an odd function because it has a degree of 3. And because it has a degree of 3, it is also cubic. So we can say the same about this. This is odd, and it's cubic because the degree is 3. So let's also talk about what this does as far as end behavior. Notice that this negative here, this negative on this one, makes this also a negative function. So this here is negative. So when we think negative, we're going to kind of think of negative slope, but it literally doesn't have a slope. Okay? It has a bunch of instantaneous slopes. It doesn't actually have a slope. So I showed you this on the other video. You can see that there is a negative slope. So I just wanted to point that out on here. But let's talk about end behavior. So on the left, it's going up, and on the right, it's going down. So left side, I would say, as x goes to negative infinity, where's my function going? My function is going up, so my function is going to positive infinity. The right side, I would say, the x is going to infinity, and my function is going down, which is negative infinity. And again, that's called end behavior. As opposed to this function here is a positive function because there's no negative in the front. So we can call this a positive function, which means we're going to think of it as having a positive slope. So if I were going to look end to end and pretend to draw a line through that, I can see that that has a positive slope. So that means this side goes down and that side goes up. So let's go ahead and talk about end behavior. So on the left side, it's going down. On the right side, it's going up. So let's write this way. The left side, this means left side, my function is going down, And on the right side, this means right side, my function is going up. So again, that is end behavior. So the number one takeaway that you want to remember with this is that number of terms is at least one less than what you see here in the degree. So here 2 turns, that's 1 less than 3. Here 1 turn, that's 1 less than 2. Here as no turns, that's 1 less than 0. But when we get to higher degree functions, we could also have what's considered no turns.